Assalamualaikum students. Today in this video I'm going to talk about an important topic of kinematics, which is basically related to relative approaching and relative separation velocities. So when we talk about kinematics, definitely we have to discuss about velocities, and velocity is having two concepts. I mean, in this we need magnitude as well as we need direction. So relative velocities are the velocities with respect to each other. So when we talk about relative velocity, relative velocity mean the velocity of one object with respect to the other. So it is velocity of any one object with respect to other. Okay, object with respect to other. So if I have two objects, let's say I have this is an object of mass 1 m1, and it is moving with velocity u1, and then there is another object. Let's say this object is having mass m2, and this object has velocity u2. Then if they are going to approach each other, the condition for approaching is u1 must be greater than u2. So what is the approaching condition? Approaching condition is that u1 must be greater than u2. So if they are going to approach each other, I can say that relative approaching velocity, relative approaching velocity, sorry for this glitch, of velocity is basically equals to u1 minus u2. So in general I can just reframe this instead of this large phrase: relative approaching velocity. RAV stands for relative approaching velocity, and it is v u1 minus u2. So it is when two bodies are moving in the same direction. But in the same way, for let's say I have two cars. This was one car, it was moving with a speed of 30 meter per second, and the other one was moving with a speed of 20 meter per second. Then basically the relative approaching speed would be equals to 30 minus 20, which would be 10 meter per second. So in the same way, if the bodies are moving in opposite direction, for oppositely moving bodies or oppositely approaching bodies, the concept is a bit different, but just due to the direction of motion. So for example, this is your car m1 or body m1, which is moving with velocity u1, and there is another body, it is m2, and it is moving towards this body with velocity u2. Now it doesn't matter whether u1 is greater or u2 is greater, because both the bodies are approaching towards each other with in opposite direction. So here relative approaching velocities will be basically u1 negative u2, because that body is moving in opposite direction. So by the concept of velocity I have to prefer negative sign over here. So here relative approaching velocity will become u1 plus u2. So this helps us out in this regard. Now there is a case of separation. For separation, I can say separation takes place when two bodies are moving away from each other. In simple words, separation means two bodies moves away. Okay, two bodies moves move away from each other. So away means if you have two bodies, let's say this is your m1 and it is moving with velocity v1. Just for the sake of difference, I'm going to write this script with v. No issue, you can use any velocities, you can name it with any velocities. Now this is a larger velocity v2. That's why the object m2 or object b would not be caught by object a. That will cause a separation. So let's say here I have a car with the speed of 10 meter per second moving with this speed, and this car is moving with a speed of 30 meter per second. Then they will separate out. So their relative separation velocity, RSV, stands for relative separation velocity, is basically v2 minus v1. So you can use this equation when the bodies are moving in same direction but they are separating out. So here it would be 30 minus 20. It means the body b will move ahead or move away from this body a by a speed of 10 meter per second relatively. Now if both are moving away from each other but in the case of oppositely moving direction, let's say it is moving with m1 v1, and this body is m2 and it is moving with velocity v2, whatever their direction is, it doesn't matter. So you can say that it is relative relative separation velocity is equals to negative v1. Basically it is v1. As you are using v2 minus v1, use the same concept, v2 minus v1. So this would give you v2 plus v1. So this is basically the relative separation velocity when the bodies are moving in opposite direction. So this is very helpful for your law of conservation of momentums when we are having elastic collisions. In elastic collisions, I will talk about these elastic collisions in momentum domain. In elastic collisions, your relative approaching velocity is equals to relative separation velocity. So the equations can be written in this way: u1 minus u2, that can be equals to v2 minus v1, or you can say u1 minus u2 is equals to v2 plus v1, or you can say u1 plus u2 equals v2 minus v1, or finally I have another equation that u1 plus u2 is equals to v2 plus v1. So these all are basically four cases. I have figured out all these four equations for you over here. The first case is approaching in same direction. This is approaching in same direction and separating in the same direction, and then approaching in the same direction but separating in opposite direction. Then case 3, this is your case 1, case 2, case 3, and case 4. So case 1, approaching with same direction, in the same direction and separating in the same direction. So before collision, this is the velocity, and after collision, this is the direction of motion of both the bodies. So here this all is basically the relative approaching velocity before collision. Before collision, because it is very much linked with momentum. That's why I'm going to refer this over there. So it would be very much helpful for you if you will get this concept in the collision topic. So this is after collision. So help, it will help you out. Thank you.